Okay, Assalamualaikum and good morning. Okay, somebody can tell me whether you can hear me or not?
Yes, doctor. Good morning.
Okay, good. Okay, for today we will start with chapter 2, which is variable. Okay. Wait, okay. So today's objective is to understand what is syntax variable operation of program language, and you're able to create an array of different sizes, able to access the array, understand different data type, and understand the constant in Matlab. So there will be 5 objectives for today. So we start with what is variable available. So syntax, variable, and operation. So syntax is particular layout of word and symbol describing variable and operation. And then variable is the stored value, which is can be retrieved by the associate name. So remember in your previous school, okay, x equals to 1, x equals to 2, the x equals is the variable, and then operation, the action taken to the variable to either create a new variable or perform a new operation. So basically syntax is just the grammar for the language, variable is the noun, operation is the verb, Matlab documentation is the dictionary. Okay. Okay, no need to worry. We focus on try to memorize this. Okay, the definition of syntax, variable, and operation. Okay, for variable, you need to know these properties. You need to know the data type. Okay, what type of variable is it? Is it a word or number, or what type of number? And then you need to know the size. Okay, is it 1 multiplied by 1? Remember the metric? Okay, 1 multiplied by 1, okay, 2 multiplied by 1, that is the size of the variable. And then lastly, the value. The value is just a number inside the variable. And then operation, this one, how you manipulate it, either using statement, function, command to create a new variable. Okay, a variable is created simply by assigning a value to its command or in a program. So basically, for example, if you want to assign a is 5, you just write in Matlab a equals to 5. So try to open your Matlab and try to do this. Okay. So try to open the Matlab and you can try doing this. Okay. So basically, if a equals to 5, you will get a equals to 5 inside the Matlab. And if you, for example, here a equals to 1 plus b. Okay, but the problem is when you define a equals to 1 plus b, b is undefined here. So Matlab is a linear processing software. So basically, if you want to put a variable here, you need to define it first. Okay, without you defining it, you cannot run the program. Okay, so this is like I mentioned before, data type. So data type, you can be either numerical, floating integer, floating point, integer, complex number. Okay, it is if the data type is a numeric. You can also use a characteristic array. Okay, so basically this one is A, B, C, D, E, F, G, and so on. And then logical. Okay, So logical is basically just 1 and 0, true or false. Okay, and structure, okay, structure is just basically the group of data array. Okay, so it is just like a folder. And then value type, it can be a constant, okay, number or characteristic or string. This one is just ABC, number is number, special number, test, metric, or it can be variable. Okay, that is the value type. And then this one is array size, like I mentioned before. Okay, you need to know this abbreviation. Okay, Scala is just basically 1 multiplied by 1 metric. Okay, means that it's just a number. Vector means that it is a number, but in horizontal or vertical. I will show it you later. Oh, metric is a, okay, you know the metric, okay, M and N. And array is just basically everything. Okay, all of this is called an array. Okay, either scalar, vector, metric, it is all is called array. So if you open your Matlab here, okay, this one is basically a command window. You can write anything here, and it will show the it will process your coding. Okay, you put in command window, and when you write the command window here, and the variable will be saved at the workspace. Okay, this is the workspace. Okay, you can see in this text. Okay, so when you write any variable, it will save in the workspace. So you can see here, a is equal to 5. So when you enter here, automatically it will create a variable a, and the value is 5. And the matrix size is, the array size is 1 multiplied by 1. And this is the type, okay, type of data. It is called double. Okay, how to determine what is this characteristic? Okay, what is the properties of this variable? So you use the coding whos. Okay, so a equals to 5, whos. Okay, or you can use whos space and then a. So basically, the name is the name of a variable. Okay, this is the size, 1 multiplied by 1 because it's just a number. This is a scalar. Byte is the size. Okay, class is the type of the number. It is double. Okay, and attribute. So you need to know what is the properties of this variable by using the whos, W-H-O-S. So you can try in Matlab. Okay, this is referring to the slide. Variable properties is also known. It is known as all variable are array. So this one I mentioned before. Everything is called array. So this one also is quite hard to explain this, but you can read this. This one I think is much more simple. Okay, Scala is just basically a number. Okay, vector is either a single row or a single column. This is called a vector. So metric is combination of that. Okay, array is all. Okay, all of this is array. But multi-dimensional array means that it is not only x and y. Okay, this is x, this is y, also z. That is called a multi-dimension. Okay, you can not limited to only 2 dimension, 3 dimension, but also as many as you want. Okay, how to create an access array method. Okay, so if you open your Matlab, okay, a equals to, okay, for example, this one using a bracket, this one you want to create a metric. So 1, 2, then use a semicolon here to create a new row, and then 3, 4. Okay, so you will create a equals to 1, 2, and then 3, 4. Okay, can you understand this? Okay, so basically you create a to fill out the number in a row, you just use space. Okay, 1, 2, 1 space 2. And then if you want to create a new number in a new row, okay, the next row, okay, basically the next line, you have to put a semicolon. And don't forget the square bracket. This one is how you want to create a this, okay, the array. Okay, and this one is how you want to access a number in a variable. So, for example, A is 241 10 9 5 7 8 15. So, how to access this number is basically A, open bracket, not square bracket, just a normal bracket, curve bracket. Okay, if 1 1 means that is here. Okay, and 3 1, so 3 is the row, 2 is the column. So you have to check 3, then this is 3, all of this is 3, and then 2, this one. So that is how you want to call back the array. Want to call back the variable, okay, number inside the variable. Okay. So if you want to use a linear index, okay, means that you don't want to use a coordinate like this, okay, you can also use linear index like this. Okay, but the numbering is something like this: 1, 2, 3, and then 4, 5, 6, 7, 8, 9. So basically, when you call A1 is just this one, but A6 is 1, 2, 3, 4, 5, 6. It will call this number. Okay. So how about we take a break? Try to digest all of the information. So in the meantime, try to check in your attendance. Okay. Make sure you slide in those according to your section and your course. If you are in SEEU, you go to SEEU, and if you are SKEU, you use SKEU. So in the meantime, try to open your Matlab. So creating an array. So next we will create an array. Okay, like the introduction before. So this is how you want to create an array. So for example, you type in the Matlab x equals to 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4 means that it will create a row of number. Okay, so x is equals to 1, 2, 3, 4. You can use either space or comma. Okay, if you use comma, it still show the same result. Okay, let me show you an example here. Okay, x is equals to, don't forget square bracket, 1 space 2 3 space 3 space 4. Okay, then you enter, you get this data, and you, if this is the command window, you type everything into the command window, and you, if you want to view back the data, you can just go to the workspace. Okay, see, it will show you 1 2 3 4, okay, in a row. So how about the okay, this one, okay, also the same result. How about if you want to do a column? Okay, you want to, the numbering is in the column. So instead of comma or space, you use semicolon. Okay, make sure you know what is semicolon. It's just basically dot and comma. like this. Okay, so you can usually this semicolon is near the enter button. Make sure you know where is the semicolon. Okay, how to do this? For example, so y is equals to 1 semicolon 2 semicolon 3 semicolon 4. Okay, if I enter it, it will, instead of a row like this, it will become one single column, and you review it back in the workspace here. Okay, 1, 2, 3, 4. Okay, so you can view the result here. Okay, this is a simple vector. Okay, this is called a vector. Make sure you know what is this. This is a vector. Basically, it has a single row or single column number. Next, how about metric? So metric is basically a number that is not a single column or single row. Basically, it's something like this. It is called a metric. Okay. So like before, you have to use space and semicolon. Okay, you can see here. Okay. Okay, you can see here 1, 2, 3, 4. So it will become a row. Okay, 1, 2, 3, 4. And then if you use semicolon, it will goes to the next line. So 2, 3, 4, 5. So you can see something like this. And then you use semicolon again, it will 3, 4, 5, 6. Okay. So I give you example here. Hash equals to, don't forget square bracket. Okay, 1, 2, 3, and then semicolon is the next line, 10, 20, 30, and then use semicolon to go to the next line. Okay, 100, 200, 300. So don't forget close bracket, close square bracket. And then if you enter, it will go something like this. Okay, if you want to view back, goes to workspace and double click. So you can see your data here. It will follow the coding. Okay, if you don't want to get confused, you can just enter this one. Okay, instead of you just goes in one line, you can just enter it after you put a semicolon. Okay, so I give you example here. So okay, if you have too much data here, you can just right click and clear workspace. Okay, you can clear it. So for this one also, you can right click and clear command window. So it will clear all the data. So I give you example. If you want to use to enter also can, hash equals to, this one is just to avoid confusion, 1 space 2 space 3 semicolon, enter. Okay, 10, 20, 30 semicolon, enter, and then 100, 200, 300. Okay, don't forget close bracket, enter. So it also will create a metric. So this one is much more easy to understand because it is shown in row. Okay. Okay. So next. Okay, this one is if you want the metric to be a value between 1 to 4, you can use this code. Okay, no more square bracket. Square bracket is just a data if you want to insert. But if you want to something like 1, 2, 3, 4, okay, you can use this. Okay, so B equals to, I want B is 1 until 5. Okay, so just 1. Okay, this one, okay, I forget the name, is it? Okay, double dot, okay. Okay, just enter, it will create a row of number from 1 to 5, and the step is 1. Okay, so the step is 1. How about if you want to start from negative? So C equals to negative 5, okay, negative 5 dot 2. So basically you want the number to be negative 5 until 2. So you just put something like this. It will create negative 5, 4, 3, 2, 1, okay, negative, and then 0, 1, 2. How about if you want to be, the step is, okay, you want the step is 1, okay, you can put this, okay, at the center you put the step number, okay, wait, so here, okay, if you want the step to be 1, okay, 1, this one is different, is just 1 step, so you just leave it like this. But if you want the different step number, so you have to put the step here in between here. So D equals to, as I give example here, D equals to 1. I want the step to be 3 until 10, for example. Okay, when you enter, it will create the number. Okay, how about 11? It also will stop at 10. Okay, because 1, 4, 7, 10, right? So as long as this one is basically just a limit. Okay. How about decreasing? This one is increasing, right? So if you want to be decreasing, you just put negative. Okay. Increasing is 2. Increasing is positive number. Decreasing is negative number at the center. So you can look like this. Okay. X equals to, for example, 10. So you want to decrease it by 2 and then until 0. So you will get this number. Okay. Okay, next, how to create an array using linear spacing. Okay, linear spacing or line space, LINSPACE, is basically you create a starting and end value and you want how many elements you want. Okay. So basically, for example, here you want a number from 1 to 10 and you want to divide the number evenly at 3 elements. So basically, it will produce a 3 number from limit 1 to 10. So this one will be done automatically. Same is here, negative 1 to 0. It will automatically, okay, divide the number evenly. So if you want the number to be divided evenly, you use line space. So I give you an example here. So y equals to, okay, LINSPACE. Okay. So for example, I want the number from negative 5, okay, and then until 10. And then I want how many number? For example, 10 or 8 number. Okay. So automatically the Matlab will create a row of number from negative 5 to 10, and the number of data is, okay, is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if you want to create a number like this, you use line space. Okay, this one is, the next example is to create an array from another array. Okay, basically you combine two arrays together. Okay, for example here A equals to 1 and 2. So this is A, 1, 2. Then B you equals to 3, 4A. So basically A you put it together inside the B. So automatically it will create a new number. Okay. So if you, this one is you want to create in a array, okay, in the same row. But if you want to create it in under a different row, you use this one. Okay, you use semicolon as before. So I give you example is A equals to, okay. So maybe I try using this 1 to 2. Also get the same answer. Okay, then B equals to, okay, 3, 4, semicolon A. So basically what I said is the number 3 and 4, 3 to 4, and then semicolon A, you put another row, A in a second row. So it will become something like this. So make sure you know how to manipulate this symbol. Okay. Okay. You can open your Matlab, try to do the example. Okay. So again, I give you 5 more minutes. Okay. This is the programming class, so you have to practice using this. So I give you 5 minutes to try to create a try to create an array. If you have any question, you can ask me.
Share screen.
Yeah, just share it.
B.
Okay, good. Make sure you don't use the curly bracket. Curly
Yeah,
bracket
yeah.
is a different thing.
I mistyped.
So be careful.
Yeah.
So can you try using linear space? So from -5 to 20, and I want 4 number. Okay. So good. Okay. You can stop sharing. I will continue with the next part.
Okay.
Okay. Thank you.
Stop sharing.
Okay. Previously, you learned how to create an array. So next part, you have to know how to access the value inside an array or variable. Okay. So basically, it's just you need to know the coordinate of the data. Okay. Sorry, my PC stuck. Okay. So here I give you an example here. A is 5, 6, 7, 8. Okay. You get the data here, and you want to extract the data. Okay. For example, 7. Okay. So B is equals to A, and then use a bracket here. Okay. Open bracket. 1 means that the row 1 and comma is 3 means that it is at column 3. Okay. Okay. So basically this is the row. this is the column. Okay, row means this horizontal line, and then this one, the second number is the column. Don't forget to put a comma. So automatically it will extract the data from A. So that is how you call data. So same as here. Okay, if you want, you have 1, 2, 3, 4 means that 1, 2, 3, 4. You have to use the coordinate to extract the data. For example, here, this is A, B is equals to A, 2, 1. So 2 means that the row number 2. So row number 2 and column number 1, which means that B is just equals to 3. Okay, that is how you want to extract the data. Okay, okay, let me clear this first. So for example, is F equals to 1, 2, 3, 4. Okay, 10, 20, 30, 40. Okay, and then 100, 200, 300, 400. Okay, and in metric, make sure you, okay, if you have 4 row, if you have 4 column, make sure all of it have 4 column. You have to remember back how to create a metric. So you have this number, and you want the G is from, okay, I want to extract the, okay, 30. So maybe 40. Okay, how to extract 40? So basically G is equals to F. So put the coordinate. 40 is at row number 2 and column number 4. So automatically G you get 40. So make sure you know how to extract, okay, access the array. Next is A equals to something like this. Okay, I think this one also an example, the same example, okay, as before. So A equals to 5, 6, 7, 8. So from A is you want to access data 1, row 1, number 2. So basically this one, row 1, column 2. Okay. Oh, for this one is replacing with a new value. Sorry. So for example, this example, you want to replace number 6 with other number. For this one, you just A equals to 1, 2 equals to 0. So basically after A originally this number, and then when you write something like this, it will replace 6 with 0. Okay, I give you example here, F. Okay, I want to replace maybe 200 with 2000. Okay, so I put F because the variable is F. Okay, where is 200 is? It is at row 3, column 2. So I want to replace the with value 2000. So automatically it will replace. And new value, you can see here, it already changed. Okay. So you need to know how to replace the value. The previous one, I show you how to display the previous value. Okay, this one is how to display previous value. Now, how to replace it. Okay, next. Okay, how to replace also the same example, how to replace, okay, row 1, column 2. So basically how to replace number 2 with 0. Okay. Okay, in the meantime, you can try it. Okay, if you want to access more than one, okay, more than one data, you can use colon. Okay, So wait. Okay, this is the colon. So this one, okay, if you want all the row in column J, is easier. I think there is example next. Okay. Okay, this is how to access the previously you just a scalar, means that a number. Okay, this one you just want to collect just one number. See, one number. Okay, in the next example is how to collect a vector of number. Instead of using a location, you use a colon here. Okay, so how to use it? Okay, so example A is 1, 2, 3, 5, 6, 7. Okay, basically 1, 2, 3, 5, 6, 7. And then I want to retrieve column number row number 1, okay, which is this vector. Okay, and then colon. This means that instead of just taking one number, it will take all the number inside the row 1. Okay, same as here. Okay, you have 1, 2, 3, 4, 3, 4, 5. Okay, you have like something like this. Okay, and then you want to extract. Okay, this one, the row means that all row. Okay, and you want to extract column 2 to 3. Okay, means that you want to collect this. Okay, I give a bigger example here. Okay, so G. So for example here, previously I just extract a number, so I want to extract much more point. So G is equals to F. Okay, I want all the row. Okay, I want all the row. Okay, so I just put a colon, and then I put I want the colon 2 to 3 to 4. So 3 to 4. Okay, means that I want all the row in the column 3 to 4. Okay, so basically this value. Okay, this one, all row, but only the column in 3 and 4. So it will extract the data. Okay, so make sure you know what is the meaning of this. This one is basically meaning all. Okay, this one is 3 to 4. Okay, so that is how you extract data using colon. Okay, next, creating a higher dimension array means that instead of just X and Y, you create a X, Y, Z. Okay. So example here is 1, 2, 3, 4, 5, 6. Okay, this one is a standard one. Okay, A is 1, 2, 3, 4, 5, 6. Okay. Now, if you look back at A, okay, you want to insert a data is 1, but this one, okay, this one is at Z equals to 1. Okay. How about Z equals to 2? You want to equals to 2. All 1. So means that if you pay back here, look back here, it will A is okay. For level 1, okay, Z is equal to 1 is this data, but because of the second one is 1, you have equal it to 1, it will become like this when you call back the number. Okay, I give you example here. Okay, I give you GF. Okay, so F is just 2D. Okay, and then I want to create a makes the 2D becomes 3D. If you look here, Okay, this is a 2D data, means that you have X, you have Y, row, column. So how to create a 3D? So you create another data. So this one doesn't care. Okay, this one is Z equals to 2. Okay, originally this one is Z equals to 1. So it just equals to, for example, 2, 1, 2, 3. Okay, 1, 2, 3, 4. So means that I assume all the number at the second row is equals to something like this. Okay, this is the Z equals to 1, this is Z equals to 2. Okay, if you look this data, okay, so it is not X and Y anymore, it is something like this. Okay, because it is 3 dimension. Okay, so not only this, you can also use, for example, F. Okay, you can create a new set of data, 5, 6, 7, 8. Okay, 50, 60, 70, 80. Okay, 500, 700, 800, 900. Oh, I forget the spacing. So basically, I create first one is this one, the original one, and then for the second row, I create another number. So this is a 3D. Okay, I hope you can visualize this. Okay, for 2D it's much more easy to visualize, but for 3D it's much more complicated. And Matlab able to create a multiple dimension. So not only 3D, but also 4, 6, 7, 8, and so on. Okay, so you have 3D, okay, higher dimension. Okay, linear indexing. So next is the linear indexing, refer to an element of an array based on a single integer number associated with to the element. Okay, so basically, I think I just give you an example, easier for you to understand. Okay, this one, previously, you call the number using 2 elements, right? So if you see here, previously, you have to put 2 elements, okay, coordinate, the row and the column, okay. But for this, if you don't want to use coordinate, you also can use a linear indexing. So something like this. For example, A is equal to 5, 6, 7, 8. Instead of using 1, 3 to get the 7, you only just put 3. Automatically, it will call the third location. So this is the vector is much more easy. But how about this metric? So for this case, for example, if you call number 2, so which 2? This one or this one? This one 1, 2, also this one 1, 2. Okay, for Matlab, okay, you have to calculate row first. Okay, that's why the numbering here, you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, for example, another box here, make sure you complete all the row. Okay, complete all the row, then start at the top back for the second row. Okay, that is how you can call the number. Okay. Okay. So this is how you can call the number. So I give you a Matlab example here. So F okay. I have to create another one. Okay. So you have a number, something like this. Okay, I want to call number 6. So what is the location of number 6? For example, I want to call it C equals to. So instead of using coordinate, originally you have to call M row 2. Okay, row 2. Number 6 is at row 2, column 3. To column 3. Okay. So you get 6. Okay, row 2, column 6. Okay, and if you want to get using a linear index, okay, you have it will be okay 1, 2, 3, 4, 5, 6, 7, 8. So you have to calculate row first, and then if after the row is complete, you go back to the next column and start from the the first row. So 6, 7, 8. So 8. If you call, you get the same answer. This is just another way to call the data inside the variable. Okay, also the same example here. Okay, this one also the same example. This one you want to replace. Okay, like before, instead of using coordinate, you use a linear indexing. Okay, okay, this one also the same. You want to replace the value, you just replace the coordinate with the indexing. Okay, linear indexing. Okay, make sure you know how to replace it using linear indexing and coordinate. Okay. Next is get value using semicolon. Also the same thing as before, but instead of using coordinate, you use the linear indexing. Okay, use semicolon. Similar to example, where is it? Yeah, example 7. Okay, this one. Okay, but this one using coordinate, but for this one, you use linear indexing. So I give you example here, 5, 6, 7, 8. Okay, 5, 6, 7, 8 is A, and B is 1, 2, 3, means that 1, 2, 3. Okay, you get 3 numbers, so you get this. Okay, if you use this one, okay, if you have a metric number, okay, 1, okay, 1, 2, 3 means that you get the data 1, 2, 1, 3, 2. It will collect this data. And the data you take will be in row, in one row. Okay, I give you example here. So M, so you have M, and then I want to take the data from 2 to 5, means that this is number 2, 3, 4, 5. I want that data. So N equals to M, I want 2 to 5. Okay. So basically, we'll extract the number from 4, 7, 2, and 5 in a row. Okay, it will collect data something like this. Okay, make sure you know the coding and the output. Okay, next is converting metric to vector. Okay. For example, here, if you have a metric, okay, something like this metric, you want to convert it into a vector, you can just put you can just put colon here. So basically, instead of a metric here, it will create a vector. Basically, start from 135, and then 246, and then 357. So it will become a vector. So this is how you want to manipulate the metric into a vector. Next is vector indices. Okay, you have something like this. Okay, you have this data, and then n is 1, 3, 5, 1, 3, 4, 9. Means that you want to take the data from 1, 3, 4, and 9. So how to do this? Okay, this is the data here, and this is the data you want to get the coordinate. So you want the number 1. Okay, this is number 1. And the data number 3, this is data number 3. This is data number 4. And lastly, data number 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 5, 4, 7. Okay. So if you do coding like this, it will get this. Okay, basically this is the N is the data location that you want. A is the original data. B is the the data you collect from the coordinate. Okay, next. Okay, I give you example. You want to replace a certain data with another number. So same as before, A is the data, N is the data location. Data location 3:7 means that the data is from 3, 4, 5, 6, 7. Okay. Okay, try to know what is the function of colon. And then lastly, A 3, 4, 5, 6, 7 is equals to 0. Basically, it will replace the data here. 3, 4, 5, 6, 7. Okay. So that is how you want to replace the data using vector index. So how about metric index? So basically, you want to, okay, for example, this is A is the data. Okay, you want the data for 1, 2, 5, 7. Okay, basically 1, 2, 5, 7. So this is the data. You want the data to be 1, 2. Okay, this is 1, this is 2, this is 5. Okay, 5 is here. Okay, 7 is here. But you want the data to be this form. So previously, this one is just a vector. Means that there is no metric arrangement. Okay, just a vector. So for this case, you want the data to be sorted like this. Okay. So for example, is 1. Okay. So this is data. So B equals to A. Okay, and the data taken from A is 1. Okay, 1. Okay. So location 1, 1, put here. And then 2, okay. 2 you need to put here. Okay. So this is location 2. Okay, data number 2. Okay. Put at this location. So you get 3. Next, you want to get data number 5 here. So this is data number 5, and then so you want to data number 7 or 8. Okay, this one is wrong. Make sure you correct it. Okay, data number 7, I think. 1, 2, 3, 4, 5, 6, 7, 8. So data number 8. So this should be 8. Okay, make the correction. And then location number 8, you put data number, this one, data number 8. Okay, this is metric index. So basically, you create basically the n is the number of data, the number, and this one is the location of the data in the new. Okay, try to understand this is okay. So I give you 5 minutes to try it out. Okay. And I will call someone to show what you have learned. Okay, Salma Nurdina, can you present to me what you have learned? Salma Nurdina.
Yes, doctor.
Okay, can you show your screen what you have learned?
Share screen.
Yeah, just share your screen.
Nampak tak, doktor?
Nampak dah.
This one is metric in.
Baca indices.
Yep.
Okay. So basically your A, can you create your own number?
Yeah.
Okay, I want you to create, you take the number 1347 and the matrix is 2 by 2. 1, 3.
One.
Okay, data number 3. Okay, I want, okay, that one is not okay, delete back.
Okay.
Okay, I want the number is 1,
One.
120. No, I want the number in A, 120, 30, 300.
One.
120,
50.
120, 30, 300. 120, 30, 300.
One, two, three, four.
Okay, and I want the data to be in metric form 2 by 2. I want the data 1, 5 in the first row, 8, 9 in the second row. Okay, good.
Thank you, doctor.
Okay, thank you. Yeah, you can stop sharing. Okay, I give you 5 minutes to take a break. Okay, and we will continue back. Okay, we continue with the third part of the slide, which is data type. Okay. Okay. So what data type is basically what type of variable inside what type of data inside the variable. Okay, the first one is the numeric data, floating point or integer. Okay, numeric class is basically just a number. Okay, numeric is a number data, 1, 2, 3, 4, 5, and so on. So this type of data can be either unsigned or unsigned integer. Signed means that you can be negative or positive. Unsigned means that all it is positive. Okay, single or double. Okay, for Matlab, usually the number is double. Okay, double means high precision. Okay, precision. Okay, means that the number is quite accurate, but the problem is it's quite heavy. Okay, quite large. So you can use a double or single. Okay, or integer. It is much more simple. Okay, and integer is much more simple and can be signed or unsigned. Okay, by default, as mentioned before, Matlab store the number in the double precision, means that very accurate but very heavy number. So example here, a equals to 5. By default, a is the double precision floating point, means that this type of number is accurate. Okay, if you want to use another type of number, how the number is saved in the system, okay, you can use integer. Okay, and 8 means that 8 bit. Okay, you can use either, if not mistaken, 2, 4, 8, I think, and 16 bit. Okay, remember that this one 8 is 2 the power of 8, if not mistaken. That is the maximum number. Okay, so where is it? So integer 8 means that the number can be saved is 2 power of 8. So equals to 8 is, you can always save until 255, if not mistaken. Should be 256, but because of the 0, it will just become 255. Okay. So this is integer. So if you use integer, okay, integer 8, it is much more faster. Integer 2 is much more faster. Integer 8 is a bit slower. But the problem is it has limitation. So if you don't want to have any limitation, you just use double. Okay. So this is just either integer or a double or single type numeric data. Okay. Next is the
Sorry, doctor.
yes.
Is there a limitation for the double for the default setting?
If not mistaken, you still have limitation for double or single, but the limitation is quite large, so you can just ignore it. Okay, if you do hardware, you have to consider this because hardware have 16-bit and everything, right? So you have to consider it. But for double and single, this is for just coding inside the PC. It has limitation, but the limitation is quite very far from what you do doing the simulation. Okay. So I suggest you use double, means that automatically double. Okay. So no need to worry about this, but you need to know what is integer 8, what is integer 16, integer 2, 4. Okay. You can Google this to understand more. Okay. Next, numeric is complex number. So you have to recall back what is complex number. Okay, basically this one. So you can use Matlab to solve complex number. And you can denote I and J, okay, for this. Okay, you can use Matlab to denote this. So that's why I think unknown you cannot use I. Let me check. Oh, still can. Okay, A equals to 3 plus 3 J. Okay. If you use J, automatically it will go to I. Okay. And one more thing before I forget. For variable, you cannot use number. For example, you cannot start with number. For example, here, I equals to 3. So you cannot use this. Either you can use A1 equals to 3. That's okay. Okay. Make sure you don't start with a number. You have to start the variable with the algebra, right? If not algebra, ABC. Okay. ABC to Z. So this is how to write the complex number inside the Matlab. And make sure you don't forget the star. Star means multiply. Okay. So make sure you don't forget this. Oh, I think the Matlab can accept without multiply. Okay. If you just put 3i, it automatically assume it is multiply. So no need to worry. And so when it comes to complex number, okay, when it comes to complex number, wait, my PC hang. Okay, when it comes to complex number, you need to know how to extract the data, the real number, imaginary. So this is the real number, this is the imaginary. And then you have to know how to conjugate, means that you change positive to negative, negative to positive here. And then absolute number means that this one using, I forgot the name. So you know absolute number, right? The square root of real number squared plus complex imaginary number squared. And then the angle, how to get the angle from the value. Okay, you use this coding: real, imaginary, conjugate, absolute, and angle. Okay, so you need to know this code if you do complex number. Z means that this number, you can replace Z with X. Okay, next part is string. So string is basically this one, the ABC character instead of number. Okay. So if you want to set a string, you need to put this. I forget the name also. You need to put this one, the open bracket and close bracket. So if you want to call, you create a string. So for example, A3 equals to, okay, open bracket with just one, okay. One open bracket, not this one, This one is different thing. So you have to use this one. So you basically create a variable A3 is a string of word. So if you check back, this is the data. Okay, it will save as a string. And this one, also you cannot do quotation. Okay, wait. Okay, if the text contain a single quotation mark, includes 2 quotation mark within the string of definition. If you want to use this one, okay, make sure you put double. Okay. So because we use this quotation mark, okay, this one quotation mark inside the coding means that you have to make sure you put double if you want to use inside the text itself. Okay. For example, A4 is So your okay. For example here, okay, if you do this, it will become error. Okay, it will not consider here. See, it will be problem. But if you want to put this one, you have to put double. Okay, so something like this. Okay, remember the whose coding? Okay, this is the characteristic of the data. So for example, you have my string here. My string is hello world. So whose my string? You just code this and you, for example here, whose A3. So automatically it will give the name of variable is A3. The size is 1 multiplied by 10 is basically how many word. Okay, this one 1, 2, 3. Space also consider 3, 4, 5, 6, 7, 8, 9, 10. That's why it's 1 multiplied by 10. So this is the size 20 byte. Characteristic is the class is means that the type of data is characteristic. Okay. So make sure you know how to use whose. Okay, this one whose. Basically, it is just the properties of the variable. Okay, this one to create a two-dimensional characteristic array. Make sure that the number of elements on each row are the same. Okay, this one you have to be careful, because it will save each of the character inside the metric. And when it comes to metric, you need to have a same length. Okay, for example, it's 1, 2, 3, 4, 5. This one needs also 1, 2, 3, 4, 5. Okay, this one is 6. 1, 2, 3, 4, 5. So this is 5. 5, 6, 5. Make sure when it comes to metric, you need to have the same length. Okay. So how to overcome this? You have to put a space. Okay, just to avoid error. Okay, because you need to make sure that the dimension of the metric is consistent. Okay. Or if you don't want to do that, you can just use this coding char. So automatically it will add space. Okay. So just q equals to char and then open bracket. Don't forget the what you call it? Quotation mark. Okay. Quotation mark and comma. So basically it will automatically make sure that the dimension is all the same. Next is a logical. Okay, like I mentioned before, you have number, you have characteristic, and then you have logic. Logic is basically true or false, or 1 or 0. Okay, if it's true, means that it is 1. And if it's false, it means 0. Okay. So how to create a logical data? You can just equals to here, logical A. For example, you have 1, 3, 0, -2, 8, 0, right? So basically, if you want to change this into true and false, you just use logical A. So basically, it will convert the data to logic number. And basically, for this conversion, anything that is 0 will automatically become 0, and any number is not 0 will become 1. Either negative or positive will automatically become 1. So this is array index, okay, using logic. So you have a data here. This is the data. Okay, this is B, is the logic here. Okay, you have a logical data 0, 1, 0. Okay, 0, 1, 0 is basically something like this, 0, 1, 0. 101, 101, and 001. Okay, same as before, but instead of just a number here, square bracket number, you put a logical to convert it. And then based on this, you use A and B. So basically, it just collect the data that is this one. The data that is 1. Okay. So for example here, 1, 1, 1, and 1. So it only collect this one, this one, this one, and this one. So it will become like this. Okay. So, okay, can you see it? Okay, how it is related? If you combine the index number, this is index. This is a numbering data, and this is a logical data. So if you do this, you get this answer. So this one also almost the same. Okay. For this case, it will only this one is linear indexing, if not mistaken. So 0, 1, 0, 1, 0, 1. So 0, 1, 0, 1, 0, 1. So it takes. Wait, let me check first. Okay. So if you do like this, okay. So it will take this data. Okay. So 0 means that it will not take this data. 1 means that it will take the second data. 0 means it will not take the third data. This is the fourth location. You take the 2 data number 2. And then this one is 0. If you look here, it will become 0. It will not take this data, and then the number 6 is, it will take the data 8, and the rest is just ignore. Okay. Okay, this is the data conversion. If you want to convert the data from others, one method to another, you use this. Okay, this one, data conversion. This is the data as mentioned before, double, single. Okay, this one is a highly precision data. This one is the integer data. You can either 8, 16, 32, 64. Okay, this is a unsigned integer, means that no negative. Okay, and then this is how to convert the data: integer to string, number to string, okay, string to double. This one, all of this is how to convert data. Okay, I give you example here. So A is this one, automatically is the double. Okay, and then you have B equals to integer 8, means that only consider integer. Okay, so integer is rounded number. So basically this is just ignore. Okay, rounded. Okay, rounded to the nearest integer, means that 10.3. Okay, you round the 3, it will become 10. That is integer. But the you will encounter problem if this one. Okay, as mentioned before, 8 is, okay, 2 to the power of 8 is 1 to 7. Okay, actually 1 to 8, because you have to consider 0, it will cap to 1 to 7. Okay, and for example, this is the double number. Okay, 256, and it is larger than 1 to 7. It will be limited to 1 to 7 only. Okay, you have to use a higher number of integer here. Okay, how can I explain this? So this is double, DOUBLE. Basically, this one is very high precision number. And remember that I mentioned that integer 28 means that 2 to the power of 8 is 1 to 8. But because we consider 0 as a number also, so the limit is 1 to 7. Okay, don't forget minus 1. Okay, so this is the limit. And then because 256 is higher than this, okay, higher than 1 to 7, it will goes into the maximum value. Okay, so if you want to get the number correctly, you have to use higher number. So integer.
Doctor, maybe because it's signed, the integer is signed, so the 255 will be divided to 2.
What?
Maybe because the function integer is signed, so have negative and positive value.
Yeah, it should have. Oh.
So it will take the half only.
Oh, yeah, I forget about that. Sorry about that. Okay, so it will reserve. Don't forget to minus 1. Sorry, I forget. This is a integer. Okay, let me show back. Okay, this one signed integer means that one of the bit, okay, one of the bit will be used. Okay, one of the bit will be used as a sign. Okay, so make sure you minus 1. So unsigned, you just use this one. Okay. Okay, so maximum number is 2 power of, okay, 2 power of n minus 1 and then minus 1. This is the formula for integer. But for uninteger, okay, unsigned integer, so you just put 2 and minus 1. Okay, so be careful with this. Okay, so where is it? So make sure you know how to get this number. Okay, so integer 16. Wait, integer. Oh, also not. Wait, let me check first. Yeah, correct. Okay, sorry about the confusion. Okay, the numbering is quite tricky. Okay, so be careful with the integer and signed and unsigned and this number. And this thing is not in the, okay, this formula is not in the, what you call, in the slide. So be careful, try to memorize this. Okay, now the next part is string. Okay. Okay, understand how to convert string. Okay, 1 to 3. Okay, this one is number to string. Okay. Okay, you have string is this 1 to 3. Okay, and you convert a is equal to number to string. You get this, and when you convert it back, it will convert every character into a number. Okay, so for this one, I'm not sure whether this is important or not, but basically number 1 is 49 in the code, number 2 is 50, number 3 is 51. So I think this one will not be answered because this is depending on the table, if not mistaken, and you cannot memorize all the table of conversion of number. Okay, number, location, and the number itself. So I think for this one, you don't need to worry, but you need to know, okay, how to change string. Okay, this is a string. Then change to number and then change to double. Okay, so next we will learn about constant. We take a 5-minute break. Okay, we will continue with the constant. Okay, we continue with the last part of chapter 2, which is a constant. So as mentioned before, in the complex number, I and j is the imaginary unit. So you can just directly use I and j, and Matlab will automatically know that it is a complex number. Another constant that you can use is pi. Okay, so for example, you have so the formula is diameter is 2 pi r, right? 2 multiplied by pi. You just write pi, pi, and then you write the radius, for example, 20. Automatically, it will get the answer. So you can use just write pi. You automatically know what is pi is. So this is just a constant that you can use. So I and f means that the number is infinity. None is not a number. So this one is basically error. If you use your calculator, you get syntax error. Basically for Matlab, it will just show you none. Okay, this one is also metric type constant. Okay, this one I think many of you don't use it, but this is just additional knowledge. So you can just use magic hand mark, and I also don't know how to use this. Okay, no need to worry for that. Okay, this one I just give you example here. Okay, so you get a equals to pi. Okay, b equals to sine pi. So you get the answer. And just a reminder that this one is this sign. If you use sine or cos, okay, this one is in radian, not degree. Okay, so be careful. If you use sine or cos inside the Matlab, this one is in radian mode. Okay, if you use your calculator, you see that there are small d inside the calculator, means that you are in the degree mode. But for this case, this is a radian mode. So if you use pi is 180, if not, okay, 180. So sine 180 should be 0. Okay, but this is Matlab, right? So pi here is just a small number. So, and you use double, means that you will not get 0, because this one is not enough number of point. So you will get a very, very small number. E means that the power of. Okay. So I give you here. So what is this mean is that 1.2246 multiplied by 10 to the power of negative 16. Okay, make sure you know what is the meaning of this one. Okay, E. Okay, and then this one, don't forget, this is in radian. Okay, of course, 1 divided by 0 is infinity. So I and f, and 0 divided by 0, you cannot divide 0 with 0. So not a number. So anything that can produce none, not a number, is anything arithmetic operation on none, such as square root of none. So you cannot square root of none number. Okay, you get none. Okay, subtract or additional of infinity, you also get none. Multiplication of infinity, okay, so you also get none. Division of infinity also get none. So remainder of 0 also none. Okay, so this one will produce a none, not a number. Okay, this is okay for this slide. I think this one is, you can try it at your, okay, you can try it in your Matlab. Okay, and submit the answer. Okay, I don't know whether this is where. Okay, you can try this. No need to worry. This is just an example. Okay. I think that's it. If you have any question before we end our class.
No, Doctor.
No, Doctor.
Okay. So if you want to practice, you can use this. This is the last slide. This is just a practice. Okay. See you again in this Wednesday.
Okay, Doctor. Thank you.
Thank you, Doctor.
Okay. Welcome.
Bye. Annyeong.